Hi everyone and welcome to today's video on defining sine and cosine. It is always good to see you here and thank you once again for subscribing and following my channel. What, you haven't subscribed? Now come on guys, do me that favor. There's a little doohickey over there. It's very desperate of me once again. I'm in fact positively needy to say, would you mind subscribing? You get to know when the new videos are out. And I have to say my style is a little freaky, a little bit unique, but I do my best to make maths accessible and interesting, and subscribers really help my channel. It means I don't sit here talking to myself, which is, to be fair, a little bit weird. If you've just joined, this is part of a series of videos relating to circular theorem. Yes, or circle theorem. And we're going to deal with defining sine and cosine. And as is normal, above me, yes, you can see it. It's up there. It's up there. It's up there. No, I'm dancing. There is defining sine and cosine and the type of stuff we're going to follow. So in my previous video, we talked a little bit about the unit circle, but I want to delve more into that. I want to understand how graphs of sine and cosine can be mapped to this thing called a unit circle. Now again, you might not necessarily have even met the idea of sine and cosine graphs, and the textbook series that I'm following, which is the Cambridge Essential series, basically does things in a little bit of a different way. I am bucking that trend. Let's do things different. Let's be individual. I want you to understand that sine has some sort of thing about vertical height and cosine is horizontal distance, and to be able to use the sort of unit circle to evaluate common angles. Now you're going to say, what do you mean evaluate common angles? I've got a calculator. Yes, I know, but over here in Australia, where one of those papers is a non-calculator paper, you're going to be a little bit stuffed if you're not allowed to use your calculator. So yeah, you may have to learn this. Right, we have already met the idea of a circle with radius 1, which we call the unit circle. So yes, in the previous video, I drew a circle and I said nothing more than the fact that if we wanted to define a radian, if we wanted to define a radian, we wanted that to be 1 unit around the circumference, and we wanted the radius to be 1 unit. And when they are true, this angle here is 1 radian with a little floaty c. And this all comes from the unit circle. And in fact, a lot of maths comes from this thing called the unit circle. And there's a lot of year 12s who just sit in my lessons go, no, not this again. I didn't understand it the first time. I don't know why. It's interesting. It's not particularly, it's a circle. Anyway, we're going to use it a lot over the time. Now, the first thing I want to do is actually I want to talk about something called a sine curve. Now, to do that, I'm actually going to load up my CAS calculator. And I'm going to draw something called a sine curve. So bear with me. Now, how do we do this? Well, the first thing I'm going to do is change my calculator into graphs and table. And the chances are, what is that all about? I don't want any of this. I'm just going to clear all of this down because that was for my year 12 lesson. And I'm going to draw something called a sine curve. Now, how do I do that? Well, first thing I'm going to do is I'm going to load up my keyboard and I'm going to go to Maths 3, let's trig, obviously. And I'm going to do sine and x. And I'm going to close my brackets. Now, if you don't have the TI Inspire calculator, I am so sorry. It is a funky piece of equipment, which is weird because I've done a whole load of videos for a different company that actually use the TI Inspire. And I raved, but wow, this calculator is awesome. And here ends the advertisement for Casio ClassPad. Your calculator will do pretty much the same thing. So what I'm going to do is I'm going to tick that box, which in a moment is going to tell me that the calculator is going to draw that graph. But I'm also going to put a vertical line. So hitting Maths 3, I'm going to put this vertical line, and I'm going to say 0 less than or equal to x less than or equal to. And what I'm going to do is put 360. Now, why am I going to put 360? Well, what you'll notice down in the bottom corner, and I'm highlighting it now, is my calculator is in DEG mode, degrees mode, which means I have to work with degrees. And what I'm now going to do is I'm going to hit that little sketch graph thing, and my calculator is going to look like it does nothing. It is this little line all squidged over to one side. Now, the reason being is my calculator doesn't know what scale to use. For the TI Inspire, I can go zoom, quick, and I could do quick standard. But the problem is that actually doesn't help. What you notice now is I've just got this line along the bottom. Shisk! What about if I go zoom, quick, and it says trig? What's going to happen with trig? And wow, ladies and gentlemen, that quick standard for trig was awesome because the calculator says, well, if it's trig, then I've got a rough idea of what it is you want to make it look like. I'm going to zoom in by drawing a box around my function. And lo and behold, what do we notice? Well, one of my students today went, wow, that's sick. And I was like, what, you're feeling sick? Don't do it here. And he was like, no, mate, it's sick. which is weird because he's Australian. And I'm like, I don't know what this sick thing is, you know? Leave a comment below. I mean, if this video is sick, then that's good. If you're feeling sick while watching, that's really not good. Anyway, back to the street language. So there is a sine curve, and I'm going to draw it on here for bigger reference, just to make it slightly bigger because I can't annotate on my calculator. Now, the wonderful thing about a sine curve is it goes on to infinity and beyond. Hey, Buzz. Favourite character. Loved Buzz Lightyear. He's awesome. Love to meet him one day, but I don't think he's real. Whole new discussion. A sine curve is cyclical. It goes on to infinity and beyond. Now, all I've done by putting this thing, so if you remember on my calculator, I did y equals sine theta. I did that line and I said 0 is less than or equal to x, which is less than or equal to 360. All I've said to my calculator is I only want you to draw one bit of that graph. And in a moment, I'll show you what happens when I get rid of that little bit here. I've actually limited my domain. Don't know why I did the quotes because it's not quotes. But anyway, let's do again, quotes. Because I just wanted some of the important information. So let's bring my calculator back. What do I notice? It seems to start at 0. It goes up. It goes down. Okay. So my important points seem to be this one here, which is 0. It seems to reach a maximum value at 90, 180, 270, and 360. Now, you'll probably notice that all of those numbers are multiples of 90 degrees. Oh, unit circle. Come back to that in a moment. What else is important to notice is that the maximum value of my sine curve, which is being highlighted now, and the minimum value of my sine curve is 1. Now, by that, what do I mean? The maximum height this goes to on my y-axis is 1, and the minimum value it goes to is -1. Now, these are all very important things for sine curves. So there's 1 and there's -1. So there's my sine curve. Later on in a video, you're going to absolutely need to know this stuff. You're going to need to be able to regurgitate it. Wake up screaming in the night whilst, dreaming about this. Now we look at something called a cosine curve. So once again, load up my calculator. And what am I going to say? So now I'm going to change this sign. Nope, we're not. Now I'm going to change this sign. I'm going to delete, delete, delete. I'm going to bring up my keyboard. I'm going to go trig, and I'm going to say cosine. Same thing, let's get rid of that bracket because I don't need the extra bracket. Want to, again, limit my domain between 0 and 360, and I'm going to draw my graph function. And what's it going to do? It's going to delete my original function, and sick, man! Still don't know what I'm doing. But same idea. So if we have a look, it's still got those same 0, 90, 180, 270, 360. Seems to have that same height of 1. And minimum of -1, but it seems to have shifted. It looks very similar to the sine curve. And actually, as it turns out, it is. It is the sine curve, which has been shifted 90 degrees, but that's way beyond what we need for this video at the moment. So there's 0, there's 90, there's 180, there's 270, and there is 360. And it seems the only thing I need to notice here is the maximum height is 1, and the minimum height is -1. So, if you were to imagine putting, I don't know, something on the wheel of your bicycle and slow-mo filming it, what actually happens is you get a sine curve. I know it seems counterintuitive and weird, but I promise you, if you were to roll that circle around and sort of plot the points, what actually happens is it does this, and it does this. It actually gives you a sine curve or a cosine curve. It doesn't actually matter. And all I'm interested in, all that seems to happen with that dot is it goes up and down and up and down. If I was to keep my wheel stationary and some way manage to keep that dot stationary, all I'd notice is my dot does this a lot, up and down. If I now move my finger, I get a sine curve. Yep, I know this is weird and I could keep this going forever, but I'm not going to. So I need the height. What has this got to do with the price of fish? Nothing. I don't understand why that. I've been using that for years in education. Still don't know why. Price of fish. Where's that come from? I'm now going to draw the unit circle. So here is my unit circle. And now I'm going to put on it values of my Cartesian plane. Now what's a Cartesian plane? It's just my x and y values. So if I now consider this as x and I now consider this as my y value, that's 1, that's 1, that's -1, and that is -1. So what does this have to do with the price of fish? Well, nothing actually. Other than the fact that I'm going to start with my sine curve. Very quickly, here is my sine curve again. 0, 180, and 360, and 90, and 270, and a maximum of 1, and a minimum of -1. Now, at 0 degrees here, what height does it have? Well, at 0 degrees, it has no height. For the sine curve, it has no height. So, where on my graph can I place this dot that says 0 degrees has no height? Well, there's only two places I can put that. That's here and here. Why? Well, there is 0, and that is my place of no height. So actually, it makes no sense to put it on the right, he says, knowing where we're going with this. So I'm now going to define this point here, all right, as 0 degrees. So I'm now going to move to 90 degrees. And when I get my point to 90 degrees, what's my height? Well, my height is 1. Now, where is there on my graph the height of 1? Well, it just so happens there's only one place on here, and that's this point here. So I now know that point is 90 degrees. What about my next point, 180 degrees? Well, for 180 degrees, I've now come back and I've got 0 height again. That can only be there, so it's 180 degrees. And as I continue around, it turns out that 270 degrees is -1. And 360 degrees returns back to 0. So I'm going to do slash 360 degrees. Now, the great thing about the unit circle, and the stuff you need to remember, is that when I draw a unit circle, 0 is there, and it works anti-clockwise. So it goes 0. I'm going to try and do this anti-clockwise by reversing this on camera. 0, 90, 180, 270, 360. If I've got that wrong way around, I am so sorry. I'm a guy. I can't reverse these things. And so that is my unit circle defined, believe it or not. And you're like, really? And I'm going to say, oh, yes, I promise you. Yes. So using the unit circle, I can now actually start mapping angles to height. You're probably going to say, well, what about the cosine rule? And I'm going to come back to the cosine rule in just a moment. All right. Because it's pretty special. Yeah, don't be rude. I'm not special. I'm just a little bit, bubbly. I now want to go and move on slightly and come back to what the cosine rule is, and we'll try and fit the cosine rule in a second. But I want you to consider the unit circle, and I'm going to look at a general point on my graph. So we now know that this is 1, 1, -1, and -1 in terms of distance, so long as I have a radius of 1 unit. So I'm going to define this point here as having coordinates x, y, because any point on that circle can have a coordinate of x, y. Happy with that so far? Okay, cool. I'm going to say that that is 0 and 360. That is 90 degrees. That is 180 degrees. That is 270 degrees. Now, you keep saying to me, well, why are you using degrees? I'll come back and convert them all to radians in a moment. But we have a unit circle. So I'm now going to turn that into a right angle triangle. Now, whenever you see a right angle triangle, hopefully the areas of maths that jump to mind are trigonometry and Pythagoras' theorem. So I'm going to draw this triangle again outside. I know that this coordinate here is x, y. I know that has a distance of 1, and I'm now going to call that my angle theta. Wouldn't it be good if I knew that distance there? Well, we do. Remember, a coordinate. If I gave you the coordinate 3, 4, and ask you what the 3 stood for, you would say, 3 to the right. Oh, I've got to think about this one now. 3 to the right. And if I said, what does the 4 stand for? You'd say 4 up. Well, bearing in mind, that's relative to a fixed coordinate, as in known as the origin. So, if I have a coordinate with x, it just means that the distance from the origin, which is here, to the coordinate is x. And that would mean that that vertical height there would be y. Why? Because y is a vertical. There's too many y's in this. Y is a question. Y is as a pronumeral. Oosh, life gets interesting. Why have I done this? Well, I want to go back to Sokotoa. Silly old Harry, quarter herring, trawling off America. And you're going to say, what are you talking about? Don't worry about it. Another video. Sokotoa. So, I want to find the sine of the angle. Now, sine is opposite over hypotenuse, opposite over hypotenuse. The opposite is y, and the hypotenuse is 1. So I've just now said that sine theta is basically equal to y. Hold on a moment. Sine theta equals y. That means my sine values are equal to the height the graph is above 0. Oh, we've already done that. Look. We did that with that unit circle. This stuff is freaking awesome. What about cosine theta? Well, cosine theta is equal to the adjacent over the hypotenuse. And well, the adjacent is x divided by the hypotenuse. So I get cosine theta is basically x. And you're like, what did you... So now we can define any point on this graph in terms of an x value and a y value, which we now can say, well, if sine of theta is equal to y, then my y value must equal sine theta. I can now say that that vertical height is sine theta. And if cos theta is equal to x, then x must equal to cos theta. So this value here is cos theta. And you're going to go, MaffsGuru, Darren, whatever, what are you talking about? Well, now I'm going to use this in theory or in practice, yeah? And we can use the unit circle to evaluate common angle values. Right, so here is my unit circle, and I'm drawing a very quick sketch. And when you do the unit circle, always good to draw quick sketches. So here is 0 and 90 and 180 and 360 and, oh no, you muppet, and 270 and 360 degrees. Right, so I know that I measure angles this way around. And I now know my horizontal distance is given by the cosine of theta, and my vertical distance is given by the sine of theta. Right, I want to find the sine of 0 degrees. Right, so the first thing I'm going to do is I'm actually going to change my pen color. First thing I'm going to do is draw a line horizontally. Now you're going to say, why have I done that? Well, bearing in mind my graph starts horizontally at 0. I've got no angle. So if it's 0 degrees, it's just a line. And the reason I draw a line is because I'm dealing with distances now. For the unit circle, it's freaking awesome. This stuff is just great. So the sine of 0. So I'm going to ask myself the question, when I have a line like this, do I have any height? What is the maximum height that gets above my x-axis? Well, in fact, it's 0. So ladies and gentlemen, the sine of 0 is actually 0. So you're going to say, all right, okay, so what is the cosine of 0 degrees? Right, again, 0 degrees, horizontal. Now, because cosine is dealing with a horizontal length, what is the length of that line? Well, because it's the unit circle, the length of that line is 1 unit. So the cos of theta, or sorry, the cos of 0 is 1. Now let's just go back. I'm going to go back to my graphs. So we had what was the sine of 0 degrees. Well, here is 0 degrees. And where is my graph? It is at 0. And what is the cosine of 0 degrees? Well, here is 0 degrees. And it would appear, reading off my graph, that the height of that would give me 1. This unit circle stuff is flipping awesome. So let's do another one. What about the sine of 90 degrees? Well, drawing a quick diagram, here is my 90 degrees there. And I'm looking for the sine. I'm looking for the vertical height of that line. Well, hold on a moment. Sine is that's 1. Because it's got a height of 1. Sorry about the flashing there. It's got the height of 1. What about the cosine of 90 degrees? Well, the cosine is a horizontal distance away from my 0 point. Well, if it's a line going straight up, does it have any distance? No. So the cosine of 90 degrees is 0. Oh, one more. What about the sine of 270 degrees? Let's mix it up. Well, let's draw a line. So here is my unit circle. Here is 270 degrees. Sine is my vertical height. Well, what is my vertical height? Why did I write -2 here? That is -1. Try that one again. So my vertical height. So when I've drawn 270, my vertical height is -1. So the sine of 270 is -1. What about the cosine of 270 degrees? Well, cosine is any horizontal distance. Well, because it's a vertical line, it's not going across anywhere. Then actually my cosine of 270 is 0 degrees. Let's just go back. Sine of 270. The sine of 270. Here is 270. I go down. There is my point. And I read across. And the sine of 270 is -1. A lot of people go, do I have to use the unit circle? And I'll say to you, if you are confident drawing the sine curve, then theoretically speaking, no. And I'll do a little bit more on that later on. But later, when we start looking at bigger angles, I want you to realize that actually the unit circle will really, really help you. Now, I want you to do this. I want you to look at the unit circle. And I want you to say, how many degrees are there in a circle? Well, it's 370 degrees, 360 degrees. 0, 90, 180, 270, and 360. Now, the fact of it is, I could continue counting around my circle. So 360 plus 90 degrees would be 450 degrees. Well, if I can keep counting around and around my circle, well, the point of it is the values repeat themselves, and I'll show you why in just a second. So the cosine of 450 just happens to be exactly the same as the cosine of 90 degrees, which just so happens to be cosine horizontal distance. What's the horizontal distance if I draw a line vertically here? It happens to be 0. Wow! Now, you're going to say, why does it have the same value? And I sort of alluded to that at the beginning. Here's my calculator screen back. I'm now going to delete this portion here, and I'm not going to limit my domain. And what I'm going to say is, can you draw that for me, Mr. CAS calculator? And it's going to say, only if you hit the button properly. So I've hit the button properly, and lo and behold, there you go. Now you're going to go, well, what have you shown me? Well, I'm actually going to zoom out from my calculator and show you what happens. And I'm going to zoom out one more time. And what you notice is that curve continues on and on and on. And the fact of it is, if I was to draw my, what did we have? I had the cosine curve. And this is a really naff sketch, by the way. Wow, it's hard to draw on here. What I notice is the difference between here and here is 2 pi, or 360 degrees. In fact, the difference between any two repeating points is actually 2 pi, or 360 degrees. And we call this thing the period. So what I know is that the point here, which is 0 degrees, and the point here, which is 360 degrees, and the point here, which is 720 degrees, they're all one. They're all repeating every 2 pi. And how many degrees were there in my unit circle? Every 2 pi, or 360 degrees. And that's part of the beauty of the unit circle that we'll do a little bit later on. Well, my computer is playing silly people at this moment in time, and so I'm going to call it a day for this particular video. This unit circle, this sine and cosine are really important, but the take home from the lesson, the take home from the video is this. Horizontal distances are cosine, vertical distances are sine, and we can use our unit circle to find key values. So 0, 90, 180, 270 and 360, and any multiple of those from thence on. Again, if you're watching, that's been great. Thanks for sticking with it. 20 minutes. I know, it's long. Yeah, you've spent more time with me than most of my friends have. Hold on, I haven't got any friends, because I spend all my time here recording videos. So if you can, subscribe by clicking that little doohickey in the corner, or a subscribe button will come up in a moment. And please do me a favor and send this link to your friends. Show the video. Do what you can to help me out. I would be deeply, deeply grateful. You just wouldn't know how much it would mean to me. All right, I'm calling it a day. There is the subscribe button. It is always good to see you, and I hope this video has been helpful. In fact, if it has, leave a comment below and just give me a little bit of love. That actually helps. No, don't love me, because that's weird. Just a little bit of love. Otherwise, there is a video loading for you over there. This is the MaffsGuru signing off. Bye-bye.